Now, dear students, today we will discuss about Kepler's law of planetary motion. Kepler's law of planetary motion. So, Kepler's given three laws. Kepler's law of planetary motion. Kepler's law of planetary motion. See here, Kepler propounded three laws. His first law is known as law of orbit. His first law is known as law of orbit. What is this law? He told that all the planets do not revolve in a circular path. He told that all the planets move in an elliptical path. Sometimes the sun remains, Earth remain very closer to the nucleus or sun. If this is Earth, this is on 22nd December, 27 December. Our position is here. On 22nd June, we are very near to the sun. That's why we filled on 22nd June, we full most hottest day. Now, 23rd March, see here, this is minor axis and this is major axis. This axis is called, see here, this is the path of the satellite or planets which is moving around the sun, and this position of sun is known as focus point. See here, this path is the orbital path of the planet. When they rotate around the sun, this path is called the orbital path, and this path do not remain circular. It remain what? It remain elliptical. This path remain elliptical. Now you see here, this path remain elliptical. The nearer region is called the perihelion region. Perihelion region. And the distal part where the planet remain at largest distance, this is called the aphelion region. Aphelion region. See at this place and at this place when the plane fly, this is December, January, February, March, 21st March and 21st September. See here, you can fill on 21st March and 21 September if same amount of hotness and same amount of coldness, that is moderate temperature is there. Now you see here, according to Kepler's law, all the planets, this is the first law, all the planets moves around the sun, all the planets moves around the sun in elliptical path, elliptical like this one path, elliptical path, and sun lies at one of its focus, and sun lying at one of its focus. See here, all of you, if this is elliptical path, this is major axis, this is minor axis, and there is first focus point and this is second focus point. What is focus point? See here. What is focus point? See here. If you tied a string between these 2 points are the focus. But what you do, you just take a stick and then stretch it and just round it over it and mark over the plain piece of paper. For example, you take a piece of paper. And what you do, you take a piece of paper and over a piece of paper, you pin it 2 pins. You just hammer it and just fixes 2 pins, pin P1 and pin P2. You take a thread and just tie it between these 2 rigid supports. Take a pencil, stretch it, and then rotate your pencil like this. It will form this line, this shape. This shape is called elliptical shape, and these 2 points are called the focus point. So either the sun will present here or the sun will present here, and all the planets. If Earth is there, it will rotate like this. For our Earth, this path will be elliptical path. For Mars, there will be some another elliptical path. For Jupiter, there is some another elliptical path like this. It means all the planets moves around the sun in elliptical path, and sun present at one of its focus point, and the sun present at one of its focus point. This law is known as law of orbit. This law is known as the first law of Kepler's is known as law of orbit. What is this law? All the planets moves around the sun in elliptical path, and sun present at one of its focus point. This law is known as law of orbit. So, according to this law, the path of the planets are not circular. It is elliptical path. Now, comes to the next point. The next law is known as law of area. Law of area. First law is known as the law of orbit. First law is known as law of orbit. Second law is known as law of area. See here, all of you. When the planet moves around the sun, this is the focus point. This is the focus point. All of you see. The second law is known as law of area. According to this one, if sun is present here and planet is present here, now if you connect this, the position of sun with the position of the planet, this is known as radial vector. If in t days, that is, let example be 5 days, the planet move from here to here, then its radius vector shifts this area in 5 days. Now, if the planet will be here, then in 5 days the planet will move this much area. And if you see this area, since this time interval, this is 5 days, and this time interval is again 5 days. If you compare the area, both the area will remain same. That, what is this second law? The radial vector. When the planet moves around the sun, the radial vector shifts equal area in equal time intervals. We can say that. But we can say that when the planet remain closer to the sun, its speed becomes more. When they are at larger distance, their speed decreases. When the planet reaches closer to the sun, the velocity of the planet increases, whereas when the planet moves away from the sun, the velocity of the planet decreases. And that's why this distance is smaller, but the area, the radial vector shifts equal area in equal time intervals. So we can say that when the planet reaches nearer to the sun, the velocity of the planet increases and it travels larger distance. But when the planet moves away from the sun, the velocity of the planet decreases. This is what? This is so second law of Kepler, which is known as law of area. Write down what is this law? When the planet, when the planets moves around the sun, when the planets moves around the sun, the radial vector, this vector is called the radial vector. What is the radial vector? The vector means a straight line which represent the position. Here position vector with respect to sun, the position vector of the planet, which is represented by straight line having arrow. Arrow means it is a vector quantity having definite direction, and magnitude is the distance between the sun and the planet. This is what vector, radial vector. Now, around the sun, when the planets moves around the sun, the radial vector shifts equal area. The radial vector shifts equal area in equal time intervals. Equal time intervals. So see here, if base is larger, this perpendicular will be, that is this length will be smaller. If base is smaller, this length will be larger, so as to maintain the law of Kepler's second law, so as to maintain the validity of second law of Kepler's. When the planet reaches to near side, as you know, when the planet moves around the sun, the gravitational force provides centripetal force. Send R. When R minimizes, velocity increases. When R decreases, velocity increases. When R will decrease, so definitely centripetal force will increase and velocity will increase. When R increase, velocity will decrease. So this is known as the law of area. This is known as second law, and this is known as the law of area. So see here, according to this law, what is the inference that we are making from this law? That as the planets move away from the sun, the velocity goes on decreasing, and as the planet reaches more closer to the sun, the velocity of the planet goes on increasing. And this is in accordance with the law of conservation of angular momentum. Law of conservation of angular momentum. This topic will be discussed in higher classes, but here only we have to discuss about what? Law of area, Kepler's law of planetary motion. The proof of this, all this Kepler's law, you will study in class 11. Now you see here, third law. This is known as the law of period. Kepler's third law. This is known as the law of period. Now, according to this law, when the planets moves around the sun, see here, the time taken to complete one full revolution is called time period. And this is major axis, this is minor axis, and half of the major axis, this is semi-major axis. This is what? Semi-major axis. Now, what is third law? According to this law, when planets moves around the sun, when the planets moves around the sun, the square of their square of time period, the square of Time period of the planet. Time period. What is time period? The time taken to complete one full revolution. For Earth, it is 365 days like this. Now, the square of time period of the planet is directly proportional. Is directly proportional to the cube of semi-major axis. Semi-major axis. Now you see here, according to this law, square of time period is directly proportional to cube of semi-major axis. What is this? Earth rotate like this. This is the position of the sun. This position is called focus. And this is major axis. This is minor axis of this elliptical path. And half of the major axis, this distance is known as semi-major axis. So according to this third law, the square of time period, the time taken to complete one full revolution is called time period. And according to this law, the square of time period will be directly proportional to the cube of the semi-major axis. This is known as third law. This is known as third law. So beta, using this third law, if the time period of one planet is known, then the time period of another planet can be determined. By which formula? T1 by T2. Square of T1 by T2 is equals to, there is K constant, it will cancel out. So it will be R1 by R2 whole cube. So we can measure the distance of planet from the sun. Because with the help of telescope, we can observe the time period of the particular planet around the sun. We know the time period of Earth. We know the distance of Earth from the sun. That is 15 crore kilometer, 1.496 into 10 power 11. These two are known. Distance of Earth, time period of Earth around the sun is 365 days and R is 15 crore kilometer. Now, if by the help of telescope we are observing the motion of a particular planet around the sun and we calculate its time period, then these three are known, then the distance of that planet from the sun can be calculated, and this is the method, this is the procedure, this is the process through which all the astronomers generally find out the distance of a particular planet from the sun. By which law? By using third law of Kepler's. Yes, now see here, these are the time periods of revolution of some of the planets around the sun, like Mercury, Venus. For Mercury it is 87.9 days, you can take 88 days. For Venus it is 224.7, that is we can take 225 days. And for Mars we can take 188 1.88 years, that is 1.88 into 365 days. Now see here. Now, if you are asked to determine the distance of Mars, determine the distance of Mars from sun, then how you can calculate? By using third law of Kepler's. T1 upon T2 whole square is equals to R1 upon R2. This R1 and R2 are distance from the sun, cube. Now what is Earth? For this Earth, this take Mars, take this R1 as Earth and R2 as Mars. Now what is the Time period of what? That is 1 year. What is the moon? Mars, it is 1.88. 1.88. We are taking time period in years. Just remember, we are taking time period in years. Now, what is the radius? What is the distance of Earth from the Sun? Distance of Earth from the Sun is 15 crore kilometer. You are finding the distance in kilometer. 15 upon. So distance of Mars we can calculate. Take the squaring. Take the cube. Now how you will solve? You can easily solve. Just what you have to do, take the squaring, and 3 you take this side, there will be cube root of this, and revert the equation, take out 15 this side, you can find the distance of Mars from the Sun by using what? Third law of Kepler's.